So, hello and welcome everyone to this 25th I Technical Lecture Series. Today we have with us Dr. Sanghamitra Goswami ma'am to give a talk titled AI Application Financial Services in Retail and Telecom. Um, a little background about ma'am. She has over 15 years of experience using AI algorithms for applications in financial services, retail, and technology companies. Currently, she works for Blue Origin. She did her PhD from the Indian Institute of Science and has a postdoctoral fellowship from Kellogg School of Management, Northwestern University. So I would like to hand over the forum to ma'am.
Thank you. First of all, I would like to thank team members to give me the opportunity to talk on AI application on financial services, retail and telecom industry. AI is a very vast topic. I may not know everything, but I'll try to get as much application as possible on financial, retail, and telecom industry from my work experience. With that, I would like to start my presentation. And if you have any questions, feel free to stop and ask me anytime. Thank you. So before talking about artificial intelligence, many things are talked by many people on artificial intelligence, and the base definition I found on artificial intelligence is by John McCarthy. I'd like to give a brief introduction of John McCarthy. His career followed the arc of modern computing, and he laid the foundation for computer time sharing, which laid the groundwork for interactive computing today. He was a professor at Dartmouth, and when he was a professor at Dartmouth, he was the principal organizer in the first Dartmouth conference in artificial intelligence. And then he moved to MIT with Margin Minsky and founded the Artificial Intelligence Laboratory. He began working on LIPS, that is Lisp Processing Language. A computer language became standard tool for artificial intelligence research and design. Then he moved to Stanford and started the artificial intelligence lab, and that lab is creating some of the technologies which we are using today. For example, robotics and machine vision, natural languages. The most notable contribution of Professor McCarthy is, which I already explained, is computer time sharing, and another he presented a paper on buying and selling by computer, what is now called an e-commerce, and everyone, all of us are enjoying today. And he was a visionary, and he predicted that in future everybody will have a computer, and which will be linked to a greater network services. So just like many definitions of AI, there are a lot of techniques. There are a lot of algorithm or a lot of techniques are there in AI, and I listed the most common algorithm and most widely used algorithm that used in all these industries. And first of all is machine learning. Machine learning use a lot of algorithm, and the top 10 examples that use in mostly in retail industries, retail, not just retail, like retail, finance, and telecoms, are name-based classifiers. I'll just give a brief overview of each of these examples and how these examples are used in predicting, predicting or use for financial service for these industries. So a name-based classifier is from family of probabilistic classifier based on Bayes theorem, and it's mainly use a lot in, like we use in a lot of identifying sentiment analysis, and then text classifications. And the advantages of name-based classifiers, it's very simple. It's like it's based on Bayes theorem and does not depend on a lot of informations. Another very popular technique used in financial or retail industries is k-means clustering. So k-mean clustering is it's group similar data points together and discover underlying pattern. So we use this k-means clustering a lot in customer segmentations. And yeah, mostly in customer segmentations. And there's another technique, classification techniques, is nearest neighborhood. So difference between nearest neighborhood k-means clustering is k-means clustering is a bottom-up approach. So in k-means clustering, is each observation is grouped based on mean value, whereas nearest neighborhood is top-down approach. It is assigned based on the similarity. So for nearest neighborhood, if there are three classification and one of the classification is not easily identifiable, then that that group is grouped together with the nearest neighborhood. And another very popular technique is a priori algorithm. I use this a lot in identifying, like working on market basket analysis. So a priori algorithm is like it's frequent item set mining and association rule, laying over a database. So back in the like back in the days, I used to work in automotive service industry, and we use a priori algorithm a lot to identify the frequency of buying. So suppose if a customer comes for tire change, how likely that customer is going to do oil change as well. So based using that a priori algorithm, we could identify that 2% of all transactions that happen that bought tire and oil together, and 60% of the customers who came for tire change also did oil change. So we could find this kind of insights from a priori algorithm, and we could use this for labor planning, pricing, inventory, and a lot of other things. One of the other techniques, which is a very popular technique, I think a lot of people use, is a linear regression. It's everybody knows about linear regression, like whoever knows AI. So linear regression is a predictive model. It's based on dependent on independent variable, assuming that there is a linear relation between independent and independent variable. So we use this linear regression model to identify in financial services, to identify why a customer goes inactive. What are the predictors that a customer goes inactive, from transactor to inactive segments. And there's another technique is logistic regression. So what logistic regression is, that like predict the probability of binary event. So we use logistic regression to identifying the fraud based on certain characteristics. So I used to work in network, and in network is like, in banking there are two systems. One is credit card and one is a network. So just giving you a background, like when you swipe the card, it goes through a network. So mostly if in your credit card you see the Visa or MasterCard, or I don't know about India, but here there are mainly four networks: American Express, Discover, MasterCard, and Visa. So I used to work a lot with network data. So I use logistic regression to identify merchant fraud. So we created a scoring, and based on those parameters, we could identify like the merchant who is going to be fraudulent, like which merchant has a high propensity for fraudulent behavior. So that so to identify that, I use logistic regression. And another is support vector machine. So support vector machine use both decision tree and prediction to identify certain phenomena. And so it's and the another technique is random forest technique. It's it's classification algorithm. It's involved many decision tree. So how decision tree is used? So again, I can give an example of fraud, how decision tree is decision tree used in fraud detection, not exactly fraud detection, but identifying fraudulent behavior. So we used to have a product. So when you swipe your card, it goes through that product and it says whether your transaction is a fraud or not. So the job of that product is to identify whether your transaction is a fraud transaction or not fraud transaction. So we use decision tree to identify if your transaction goes through that product, and if it's a fraud. If it goes through that product, how much money we save to save in fraudulent behavior. So how much? So you is like if my transaction goes through the product, we used to create a decision tree like my transaction goes through to that product, yes, no. And then again, if it yes, how much money we save, how much money we do not save, like that kind of an behavior. And we create a decision tree and finally identified like how much money we could save by using that product to save millions of fraud. And another very popular technique of machine learning is forecasting. We use forecasting a lot in predicting demand for like new product as well as existing product. And again, this artificial neural network is used is a machine, AI techniques, which is you mimic the properties of biological neurons and try to predict behavior. Natural language processing is again a very popular artificial intelligence technique, which is also used in this kind of industries. And we already see the usability of that technique on like Siri, Google, Alexa, those products. Another very popular technique is computer vision, which is like technology behind self-driving cars, facial recognition, optical character recognition, and even for medical imaging and interactive gaming. Robotic and automation is a very popular technique used in retail industry, even in technology for warehouse management. So warehouse management is like robots are used more heavily used in Amazon warehouses to not take packages from places to places, even for delivery, and making the package ready for those kind of activities. And also lately in our manufacturing unit, we use robots a lot, because lot of things like suppose there is some testing happens some of the engines, so the engineer has to go and manually enter all the activities in a systems. And when there is a manual intervention, there are it's prone to a lot of errors. So we are using a lot of robots doing those kind of activity as well. And then recently the ChatGPT, like it's been a heavily talk topic in recent days, like about ChatGPT. So financial services, what are the adoption of AI and how it evolves in AI since 1980s? So financial services, I would say, everybody knows that like AI needs a lot of data, and financial services could tap into a lot of data at a very early age. You know why? Because of the advent of credit card. Like when you give a credit card, you already get a lot of data from the customers and financial. And then when you swipe the card, you get a lot of data. Like those data are recorded uh, from a very early time. So financial service is one of the early adopters of AIs, and it's mostly like initially it used for fraud detection, credit scoring, and risk management. Like in terms of fraud detection, identifying like whether it's a fraud or not, then credit scoring, like based on your score. Credit scoring is a very important parameters of all the banks. Like based on your score, they decide like how much loan they are giving it to you, how much credit limit they will be assigned to you, those kind of thing. And risk management, like how risky you are as a customer, because financial services, they are very like risk is a very important factor of them, or in terms of like losses, also in terms of you know um, like keeping their capital safe. Another application of AI on AI on financial services is a natural language processing, or support vector mechanism to use for predictive analytics. Like we use like sometimes like sales go down, and so he is to identify why the sales is down. Is it due to certain phenomena, or it's due to some of the product we don't use, like that kind of things, that kind of insights we used to get from applying these techniques. And computer power and big data enables models. Like if you see after the 28 recession in US, like fraud and anti-money laundering became a big issue, and we use a lot of like big data and deep learning models to identify AML, like anti-money laundering models on fraud models. And another is rise of chatbots and robo advisors, like it provide financial advice to the portfolio client. And also the natural language processing, we use a lot of natural language processing to analyze customer feedback in terms of customer complaint, so that we can engage those information in our marketing models to identify the right kind of marketing for different segments. The retail industry, the application of retail industry, they adopted artificial intelligence relatively late, but the adoption is extremely fast. And Amazon started using artificial intelligence for demand forecasting and inventory management. So they have Amazon. When Amazon became very big, it was extremely important for them to identify the right demand, and also the keeping the right kind of inventory. And they use artificial intelligence a lot to identify demand forecasting and inventory management. And also the Netflix, you must have seen like personalized recommendations, like when you like browse on Netflix. It's not just Netflix, but it's an example. Like they recommend movies, they recommend show, and it's heavily used by the use of artificial intelligence. Another use of artificial intelligence is chatbot and virtual assistants helping customer services. So it's like when you call, there is an automated message, and even the virtual assistant, when you like open a website, like a small window pop up and ask like what kind of needs. So that's also a, use of artificial intelligence in customer services. And automated checkouts introduced by Amazon Go. So around 2015, Amazon started a lot of stores without like human present in the store. So you can take a card, go inside, take your goods, and then you can automatically check in. Everything gets recorded, and it's a classic example of AI. And in retailer also use dynamic pricing, AI to dynamic pricing, that we also use AI for dynamic pricing in technology industries. So based on certain rules, like I'm just giving an example, like there is a lot more in the algorithm that rules, like after every five, like a lot of analysis also goes before that, like after five after five customers, and if there is no competitors, then the price will be this much. Or like how do I fluctuate, increase price or decrease price, so that we can keep the same demand. So for that, artificial intelligence is used for dynamic pricing. And then another is robots in warehouse, which I all have already talked. And telecom, how the artificial intelligence is used in telecom. So it used heavily on network management, fault diagnosis, network optimization, predictive maintenance. So before and so in recent years we have seen like a, like whoever used the network, like before you use a lot of problem, we saw a lot of problems in networks, but current uh, in recent years, due to use of artificial intelligence, like artificial intelligence was used like for a long time, but with the improvement of algorithm also, we could improve the network performance. So how it's like before, like they know like where the issue is likely to happen, and networks are prepared so that before it became an problem, they could solve the problem before it it had effect on the customers. And also fault diagnosis, if there is a fault, they can diagnose it at the early stage. And another very interesting application is network optimization. So if there are some event happening at that area, how they can allocate the network, like they will need more network in that area and less network in other areas. So how they in the allocation process, they use a lot of artificial intelligence. And again, chatbot and virtual assistant helping customer service the same way it used in retail services. And fraud detection. Fraud is a major issue in telecom industries. So fraud, so we use a lot of artificial intelligence to identify fraud. And also the forecasting, demand forecasting for customer demand, we use different artificial intelligence techniques. So with that, like I would like to give you give you a case study, like two case studies on new forecasting, as well as like forecasting and inventory management. So it's like artificial in industry, it's not like you are not giving a data and you have to apply your algorithm and give the results. There are a lot of process goes in there. Like first you have to identify what is the problem, and once you identify the problem, what issues it's going to solve for your organization, how much money you can save by by using that kind of application, and you have to convince other people, and also whether you have the right resources or not. If you don't have the resources, how you can gather your resources, or how you can distribute your resources, and then what is the timeline. So there are a lot of planning happens, and for that you just don't need you need definitely artificial intelligence skill, algorithm skills, data skill, but also you need other kind of skills. So I can tell you and also the in terms of forecasting. So we do mostly we are involved into forecasting new product as well as existing product. So existing product, like artificial intelligence, like applying artificial intelligence is relatively easy compared to new product, because to apply any kind of artificial intelligence, like we need data, and data is something very crucial for a technology product, because the products keep changing and you don't have a long history. And when you don't have a long history, sometimes this our techniques does not work well, and we get flaw, like there are a lot of flaws, like faulty results, and the accuracy, like forecast accuracy is relatively low. So we use a lot of bottlenecks in applying this artificial intelligence techniques. So so it requires a lot of human intervention to see events at a very greater detail. So I can give an example of new product forecasting. So first of all, you have to define the problem and what is the objective of the problem. So the problem we encountered in forecasting one of our new product is, every time we do new product forecasting, like there are no set methodology, and every product is different, and we don't have any history. And not only that, we don't have any similar products, so that based on like similar product, I can like get insights, and then do create forecasting for that product. And so as a result, there are lots of assumption based and intuition. And then key concept we're missing from the forecasting methodology, like promotion, cannibalization, brand value. I don't know if you know cannibalization or promotion. Promotion is like, yeah, you must be knowing, like if I buy this product now, I get like 20% discount, so that kind of promotion. Cannibalization is like if there's two product going at the similar time, selling at the similar time, if I lower the price of one product, the that product, like the sale gets higher. So it's it's a cannibalization of from the higher selling product to lower selling product. And then that time we used to forecast around 60 products in a year, and every product we used to do manual forecasting. So we wanted to create a forecasting methodology, so that we don't have to do we don't have to do manual forecasting for each and every product. So and we wanted some level of automation. So complete automation, I already told you, it's not possible for new product, because as I told you, every product is very different, and some products we do not have any product that is similar to that product, which we can tap data for sales history. So and we wanted to create some level of automation while improving forecast accuracy as well. So how you define object, it's like we consolidated forecast model to facilitate the demand planning. That was the objective. And I don't know, like demand planning is a very important factor in the supply chain. And so in supply chain, everything starts with forecasting. So once we forecast the product, that goes to the procurement, and then based on that demand, they create the orders. And when they create the orders, then our OEMs, they start producing that. And then the stores gets prepared, they do the labor planning, they do the transportation, and also marketing also does all the promotion, advertising in based on that demand. So demand forecasting is a very important crucial step in supply chain. So what how we are trying to identify the right forecasting methodology for this new product is we decompose the sales to identify the baseline demand, because it's very difficult to identify the baseline demand, like actually how much uh, is the actual sales, because every time something or the other is going on, either it's a promotion, either is a discount from some other product, or some a seasonality. I mean, so identifying the right baseline is very important. And second is like, what is the promotion driven lift, sales lift, or what is the discount driven sales lift, and to explore the level of seasonality that is used in all these on the product sales. And based on these criteria, we wanted to build a consolidated data driven forecast model, which is scalable as well as automatable. So what is the key task? So we had to identify the key task. So we had to gather information on promotion, we had to gather information on seasonality, we used to gather information on price reduction, like if the similar products if we reduce the price of the similar products, how much sales lift the other products enjoys, and how much demand it goes from this product. So that kind of information. So for that, it's to get those information, we had to work with a marketing team, we had to work with pricing team, we had to work with like procurement team. It's like working with different team is also a very important in this process. And quantify and also like we had to identify like historical how the historical campaign has an impact of the sales lift, and based on like and how the sales allocation methodology is applied for cannibalization of existing product. So and also we had to work on like uh, few years of sales to identify the year round of seasonality, like if we have to give some lift in terms of sale based on the seasonality, how you interpret that, how you identify that. So this is a kind of just to give you an overview of the sales historical sales of the similar products, like all new products. So this is, I don't know if I can use this. Yeah. So this I mean, mostly in our industry, when the product is launched, we get the highest sales, and it kind of dies down, and then it gets lift due to factors like cannibalization, promotion. So when you see this lift, it does not happen on its own. Like there are some phenomena that pushes this kind of sales lift, and to identify, and that is why like identifying the baseline of the sales and how you give that lift to sales for each product is very difficult. So we first we identified the without doing anything, we identified the historical sales, like, or sales pattern of different products, like different new products. And then we identify like how promotions occur at different periods of time, and how different promotion has impact on sales. And then we, based on that, we created a baseline, like identified a baseline, like, so if there is so this is if there is no promotion, then we consider that is a baseline sales. And then we created a baseline. So here, so ultimately, like all technology product, I told you, like initially we had the highest sales. Like even if you don't do anything, you are expected it's expected that the sales will go up, and slowly it will die down. But at different point, there are different baselines. So to identify the baseline, this is how we identify the baseline. And from baseline, we identified how much sales has increased from here to here, and how much sales lift we are getting due to different promotions. And this is a promotional lift, and this is a event driven lift. Event driven is like, suppose some natural phenomena happen, like during COVID we see a lot of spike. I mean, COVID is not a very good example because it does not happen very often, but I'm just giving an event driven lift. So during COVID, hotspot became very popular, so our hotspot demand went up, like, it spiked, and that's a event driven lift. And then based on the promotion and event driven lift, we came up with different promotional lift factor for different product. And and then we identified like net promotion sale, what is actual sale minus estimated promotional lift. And then we did a seasonal analysis. So different season has different lift. So for example, in US, we see lift during Christmas and Thanksgiving. So what is the seasonal lift for this kind of product? And based on that, first we identified the baseline. This is the baseline. And then we created the promotional lift. So certain promotions, it happens all the time. So we created a promotional lift based on some common promotions, and give some lift to the sales, like how much sales we can expect with this promotion happens. And then we created the seasonal lift for this kind of, after promotion. Then we use seasonality to create actual sales. So first we created the baseline, then with promotional lift, and then with seasonality, what is the sale we can expect from this kind of product. So if you can, and then with that we are able to automate the process with artificial intelligence. Like these are the rules that we're going on our algorithm, and we could automate that process. And as a result, we could save on right demand, right customer experience, because if we don't have right product in the stores, we lose a lot of customers, because customer comes and they go back and they go to our competitor, because you get the same product in other stores as well. We could save money on transportation, labor planning, and it became a huge benefit to our organization. So the result is new methodology, like forecast accuracy from before, like with all the assumption driven forecasting, it was like the accuracy was like very low, like with like this automated forecasting, we could improve forecasting accuracy from 40% to 15%. So and also like time to generate new forecasts is reduced by over 80%. Since it's an automated process, it's not a manual process, we could forecast products at a much faster rate. And also we could help collected the data, whatever as insights we created to develop that forecast. We could use that uh, for to continuously improve our forecasting accuracy, and then reduce manpower definitely. Like 60 products we have to create forecast for each product. At the same time, if we have to create forecast for 4 products, then we need 4 people. But if we can automate that, we can reduce it to 1. So it created the reduced manpower, and also it's increased like better forecast. So another case study, this I included because if somebody wants to be a data scientist, what kind of work he can expect before they dive into actual AI modeling. Because for all kind of AI data, as I told you, data is very important in organization. Getting the right data is very difficult, and it's not getting the right data. The data are always in different system, and how you make them talk to each other and get one thing, that is very difficult. So this how it started, like we did not have a proper visibility to how much weeks of supply we have in its stores as well as in our warehouses at a very granular level. And again, if since we did not have that kind of information, it we suffer from right promotions, we suffer from good customer experience. And some stores will have redundant inventory, some stores will have no inventory. Then even we did not have proper transportation, and then labor planning were weak. And also it had a lot of impact on your procurement. And we don't know how much inventory we have, so we keep ordering a new inventory. And then to get rid of the redundant inventory, used to create like promotions which was not relevant for certain times. So we used to face a lot of issues. So there was a need to create an integrated supply uh, data to give visibility to all these departments, right from procurement to marketing to transportation, store, everybody. So we it's like, as I told you, like in organization, it's just not like applying your algorithm. There are a lot of process goes before that. So we used to had to identify what we did not have. Like we have a lot of reports, and what it is missing from there. So we had to do a thorough study on that. So we saw that like inventory status report, there are a lot of reports, and those reports are not adequate to give that kind of information. As a result, we had high lead time for orders, high out of stock level some stores, and while excess inventory, and transportation cost I already told. And then we found the problem, but how do you measure that? So we decided on measuring like weeks of supply. How much if we can measure what is the weeks of supply we have in its stores, it will give us a very good visibility at, like, if we can do it at a granular level. So granular level is like its SKU level, like each item level, and at the store level, at the channel level, and at a company level. Like not it's like not tracking only at like product level, but also the each level, like what is the weeks of supply we have at retail stores, like each stores, what is the weeks of supply we have at the channel level. So we have different channels, like retail, then we have like direct to consumer, like if you go and buy a product and if it is not there, then we ship it, that is like direct to consumer. And some products are not available in retail at all, so it is like completely web, so that's another channel. So we wanted to measure weeks of supply at each channel level, and also as a company as a whole. So why the company as a whole, it's important to measure company as a whole, because we know how much worth of supply we have, so that like we can, if like some stores, suppose like some stores does not have inventory, we cannot say, oh, we don't have inventory at all, like we can get inventory from other places. So it's important so that we can measure at each level. And then we have to identify like how the output has to be delivered. That is also very important, because there are a lot of customers, like store people, how they want to see it, how the procurement people see it. Like not everybody is equally conversant with technology. Some people may want it in the PowerPoint form, like senior leadership, they just care about one number. Or how or maybe store level people, they care about a detailed report. Like we had to identify like how we can give this kind of information to different people. And yeah, and what is the lead time, like how soon we have to finish this product, and what kind of benefit it will create for the customer. So it will like reduce out of stock rates, and that will improve customer experience and sales, reduce excess inventory and cost with better visibility and planning, and reduce ordering lead time. So project roadmap and key task for delivering the project is like gather user requirement. Like as I told you, one requirement is what format they want to have that information, and what level they want to have this information. We have to align. So when you have like when you talk to customers, they will say, oh, I want this, the other person say, uh, it's not possible to get to everybody's request, but we have to get alignment so that you can give the best possible value. And then work stream, like who will work in what kind of work, like my team will be working, what other team will be working, how we can coordinate that kind of effort. Then project alignment. So when we use, this is a huge project and a lot of parties are involved, so you need to create project plans, and you have to identify what is the deliverable, like what you are giving in like 6 weeks, what you are giving in 6 months, or what you are giving in 1 year. So you need to plan everything, and if you plan how you are going to execute that, like what is the methodology. And then driving adoption, like how they are drive the adoption, like you have to inform the business group, gather feedback, and how you improve the process. And key challenges, it's there are a lot of challenges we face in executing this project. So keeping all project team grounded on the project vision, because everybody has their own priorities, but keep everybody on grounded, and make them to this product vision was one of the main focus. And then integrate output from different PO systems. So as I told you, there are different systems and getting data. So things like if some in some systems the product will say as product, some system it will say as items, but it's the same thing. So how you connect those two things together? Like, I'm giving a very simple examples, but getting things from different systems and making it uniform was a very difficult task. And then inconsistent forecast of inputs of weeks of supply. So how you identify weeks of supply? What do you need? We need, first of all, we need all the item level information, like product level information. You need sales, you need forecast. Oh, you need inventory, you need forecast. So keep giving everything, like it's a very difficult task. And inconsistent forecast, like some people some products are forecasted week level, some products are forecasted like daily level. So you cannot get like different forecasts for different things. We have to get uniformity of the forecast. So how you can give that uniformity to the forecast, that was a big challenge. Like, you just cannot decide, but you have to get inputs from everybody and get to a consensus. And different skew mapping followed a short deadline, as I told you. Like, different skew has different names and like different category. So it was hard, like say. And and also identifying and auditing and integral real-time data sources. So we wanted to build something real time, and identifying like how and when you wanted to build real-time information, that your data has to be very robust. And what kind of auditing algorithm we applied, that was a big challenge. And ambiguity on user requirements, like some people don't like, not everybody knows till you deliver the product what they are looking for. So you face a lot of ambiguity from that perspective. And how do you align everybody on that? And then educating business teams on like new tools, new tables, that was a very big process to it. As I told you, it's not just like writing the algorithm, but there are a lot of process goes here. And then ultimately we created the code, released the first version after accepting the 3 weeks, then completed, like we followed up, then completed, and finally we completed the project in 6 months. And what is the business outcome? We reduce week of cover by 2 weeks over 90 days, and it reduced the excess inventory. So we were able to rightly give information to all these business partners what is the weeks of supply at a very granular level, and it reduces like excess inventory from 2 weeks to 90 days. Sorry, 90 days to 2 weeks. And it reduce out of stock by 300 basis point and improve overall customer experience. And it's also reduce lead time, ordering lead time, 3 weeks on average across all devices. And it's also increased promotional returns. As I told you, since we did not have a very good visibility, uh, uh, on like the inventory, we used to run a lot of promotion which was not actually beneficial to our organization. So when we have a good visibility at a very granular level, we could increase promotional returns by 300 basis points. So yeah, so that's the two case studies I did and my team did on different organizations. And now it's like time for regenerative AI. So it's regenerative AI will fundamentally change how model and strategies built because of self-learning capability and capability, original content based on output like text, images, music, 3D objects. And this ChatGPT, like which is regenerative AI, is a it's a breakthrough technology based on LLM, like large language models. And how it works, like I don't know much about ChatGPT, like I'm not an expert, but what I know, it works, it runs the model. Why it's more accurate? Because it runs the model in very large amount of data set in a unstructured and unsupervised way. And what actually it does, it's predict things like so a lot of so what is, like if you say a cat in, it will predict like in the head, because it has so many examples of that sentence. Like it's it can predict much accurately than other technologies. So 10 possible use cases of regenerative AI in financial services is like closed tech and can be automated, is customized marketing, like in terms of like what like customize in terms of what I want, what you want, what other person want, like that customized marketing. Then document processing, definitely we are seeing the benefit of document processing in chatbot. Then information validation, definitely, like as I told you, like identifying the fraud, like if I give my information to buy something, whether it's like I can validate that, like, and based on the validation I can approve your transaction. And then customer service, definitely, like we already saw, like customer service in terms of like call centers and pricing and fee optimization. So it's like it's low stake. And high stake is risk identification, portfolio construction. So I would say these, like product selection, so a risk identification and portfolio construction, like current chatbot, like it's like it will be difficult to use for without any human intervention. Then product selection, automated relationship management, memo writing. I think memo writing also needs some kind of human intervention, because it's, you have to check like till it gets proper. So yeah, these are few low stakes and these are few high stakes application of chat GPT in financial services. And lastly, I was asked to talk a little bit about like what is the requirement for a data scientist and how are the interview techniques in these industries. So prerequisite is definitely you have to love data, and you have to have analytical mindset and quest for logical reasoning and some programming skills, because most of our companies, like even in our team, we have to like when you apply for data scientist, you have to write like on the spot programming. And it's better if you have familiarity with math, science, or linear algebra. But I would say this can be learned, and this is not mandatory. Even if you don't have this kind of experience, you can definitely apply. And this understanding business operation is very important. I can give you a lot of data, but to get the right insights, you have to understand the business. As I gave you already few examples, right? What is the problem, what you are solving, and how it's helping your organization. That kind of insights is very important, and then only you can attack the problem in the right way and give the right insights. And you have to have a learning attitude, because things keep changing, even the technology keep changing. So you have to be ready that you have to learn all the time. So yeah, like I started my career with SPSS, and now it's like I maybe I learned like lot of techniques, a lot of databases, lot of algorithm, and some algorithm became obsolete, but still I to keep myself up to date, I have to keep learning. And excellent communication is very important. Like whatever you get out of your algorithm, whatever you get out of your data, you have to communicate well, so that you can convince others that by using your insights they will get benefited. So excellent communication is very important, be it's writing, because you have to keep writing mails all the time, or be it's like presenting, you need good communication skills. And skill requires, I would say, Python, R, SQL is very important, and advanced Excel, data visualization like Tableau, PySpark, those are important tools. And machine learning algorithm, like, and then soft skill, like as I told you, verbal and retail communication, storytelling. So most of the data scientists nowadays, at least the organization I work for, are tested as equally on Python as verbal and communication skill. So this, like, both the skills you have to work on. And I would say, if you want to apply for some organization, try to do some projects. Like suppose you want to apply in Amazon, like retail, try to create, like nowadays there are a lot of data available in the web, try to create a project so that that is useful to them, and then you can communicate, see, I can do these things, and this kind of insights is useful to your organization. So try to understand their business, try to do some projects with data, and show them like what you are worth of. So that is something I think you can do, and that is helpful to crack the interviews. And career path, I would say there are major differences based on types of organization. Like some organization have metrics organization, some organization are lateral organizations. So it's like mostly like it's this is the org structure is like there'll be a chief data officer, then director of data science, and director of data governance. It's a very important thing, data governance. Then data scientist, data engineer. Data scientists are mostly analysis, automation, and those kind of thing. Data engineering is like creating the pipeline, which is also very important aspect of data science department. Business intelligence engineer, like creating report and doing analysis, that kind of thing. And data governance is like data stewards, like who gets like uh, keep like from the operational perspective, right, the right data, right definitions, right accuracy, so those kind of things. So yeah, so data scientists, like they focus on machine learning. Data engineer creates data pipeline, focus analytics. Data science manager is a people manager and also a data scientist. And director of data science and head of analytics, like you have to be ready for everything, right from data science to data pipeline to data governance, everything. So yeah, with that I would like to conclude my presentation. Thank you. If you have any questions, I'm ready to
Oh,
answer.
hello. Thank you, ma'am.
Yes.
Thank you so much for such a wonderful talk. It was indeed very interesting and engrossing, and especially when you took us through those two uh, study cases. It gave us first-hand experience of how the industry practices AI products building and all. Thank
Thank
you
you.
so much for such a wonderful talk. I'll quickly read out few of the questions that we got over the comments in YouTube channel. So I'll start with a few of my own questions. Uh, the first is like when building AI systems for retail businesses, how is training data obtained? Like, do we collect it from the data using the infrastructure that the said business has already in place, or do we get it from some free or paid sources from in the market? So,
Depends like what kind of problem you are solving. Like if you solving like sales, like if you are trying to identify why our sales is low, like if you want to use like AI algorithms, so those data is always already available. Like um, but certain sometimes, as I told you, the new product, like we don't have much data on that. So in that case we source data from outside, like we source data from social media sites, or we source data from other systems. So it depends like what kind of problem you are working. So that's, as a data scientist, that is your job to like identifying what kind of data you need, and where you are going to, what kind of problem you are trying to solve, and how you are going to get the data. So it's always situation specific.
Oh,
So I would
thank you,
say
ma'am.
it's and yeah, and mostly data is, I mean, most of the organization store data, so data is not a problem, but getting the right data is a problem.
Right. Oh, thank you, ma'am. The second question is like, given a problem, what is the procedure to estimate the feasibility and the profitability of that product? And later, how would you evaluate the success of that AI product that we built? I mean, it's a bit generic question, but we could answer this.
Um, Again, like what problem you are trying to solve, you have to identify like first of all, when you are trying to identify the problems, try to quantify those problems, like not just like, okay, it's it is like we have a low customer experience and we have a high lead time. Like if it's a high lead time, like how much, try to estimate the problems, like try to quantify the problems. And once you quantify the problem, you see like if you implement some AI system, what is the how expensive is that, how much time it's going to take, and is it going to um, add value to my problems. And then once you implement, you can see like you can go back and see, okay, these are my objectives, these are the problems, and these are the objective. Like the problem is I have a higher lead time, like my the problem is the order lead time is now like 60 days. I want, like the objective is I want to reduce it to 20 days. And like I have AI system, so how much, like if I read if I have 60-day lead time, this is my cost. And if I apply this AI system, is it going to reduce my cost based on like feasibility of my AI system? Do I have the right manpower? If I have the right manpower, and that, do I have the right resources? So and then once you implement, so if you, based on that, you have decide to go ahead and implement the system. And once you implement the system, you identify whether you are able to reduce the lead time and reduce the cost you associated with that. So like quantification at every step is very important.
Oh, okay,
Am I
ma'am.
able
Thank
to
you so
answer
much.
your question?
Yes, ma'am. Yes, thank you so much. And like the
Okay.
next question is also on a similar line. So, but this is with respect to financial sector. So this
Mhm.
question is from Parismita Gogoi. She says, how to design a financial data science project, how to formulate the problem, how about the data security issue?
Yeah, data security. Yeah, it's a, I mean, formulating a financial service problem is like it's different from problem to like, I would say financial services, like it's mainly has three main within like three categories. Like one is finance, more like broad category, one is marketing, and one is risk. Risk is a very important important aspect of financial services. And risk is like kind of building a credit scoring, and then CLI, like credit limit, like how much credit limit you are giving to customers. And then marketing, like we do all kind of marketing. So we used to do like customer segmentation. So in financial services, like the customers are divided into three main factors of segments. One is inactive, one is transactor, and one is revolver. So transactor, inactive is they don't use your card, and then transactor is they just buy but they don't keep any balance in the credit card. And revolver like keeps balance, and revolver segment is the most profitable segment for most of the banks. They are like costly when the economy is not good, but they are they are like profitable customers to the bank. So it depends on what kind of problem you are trying to solve. So, and finance, like finance also tries to the pricing is a very big thing on marketing as well as finance. So how, when you formulate a problem in financial services, the it's so it's so the when you try to solve the problems, its category is different. Like marketing problems are different, risk problems are different, finance problem are different. So you have to know, like, again, like what you are trying to do, what kind of problem you are trying to solve, and what kind of like how you are use what kind of techniques you need to solve those problems. So its formulation is very context specific, and it's very category specific. That is I think that is the answer to your first question. And what is the second part of the question?
Like it was with regard to data security, ma'am. Like how do we take care of that?
Okay. Yeah, data security is a very important aspect, and you take care of the data security all the time. And how much information you are revealing, that is one aspect. And then where you are getting the right data, that is also very important in financial services. Yeah, so yeah, those things are very important for and also like revealing the information, how much information you're revealing to whom, like every, like there are data governance, like what information you are supposed to release and what information you are not supposed to release, to whom and at what extent. And there it is all dictated by the data governments.
Thank you, ma'am, for this elaborate answer. So the next question is like with reference to your presentation. This is from Hriday. Like he says, for an event-driven lift, is the intensity of the peak, that is the difference between the baseline and the top of the peak, also an important factor? Is that also an important factor? The difference between the baseline and the top of the peak when we talk about event-driven lift.
It's like top of the peak, like I don't know, like does it mean if there is like 5 event driven lift, it's like we only consider the peak event driven lift, or like all
I think,
all lift?
yeah, Rita, if you could elaborate your
Hi.
question.
Yeah. So the question is basically, ma'am, so when we talk about multiple peaks, so the peaks will have different heights, like, so the peaks will have different intensities. So are we considering all the peaks as same, or if a peak is having more intensity, the difference between the top of the peak and the bottom, does it, like do we take that into consideration as well?
There are two facets to that problem. One is like definitely peak, and one is like how what is the occurrence of those peaks. So how frequently that occur and how much they occur. So it's not just like the highest peaks, but also occurrence is important. So it's, I would say, from calculation perspective, it's mostly average. Like don't take it at like average value, but it's like also the occurrence and the peak is also, both is important.
Thank you.
Thank you, ma'am. We also have some acknowledgements in the comments, like Shishi Kalita and Hiranyanath, saying that it was an excellent session and that it was a very comprehensive presentation as well. Following that, like we also have a question from Shishir Kalita. The question reads like this, ma'am. Do you follow any standard flow to execute the project? How do you get the feedback from user and optimize the business objectives? How frequently do you get the feedback?
We have some we don't have a standard project process all the time for from start to finish, but we care for some standardization in some of the stages, but it's differ from organization to organization. Some of the organizations like financial services is very process driven, and sometimes I would say by the time you develop a model, like it takes a long process, and sometimes the relevance of the model goes down because it has to follow a lot of procedures, because it's but retail, it's not always like that. So it's and if it is related to security, the process are more robust. So it's it's very organization driven as well. But yeah, like some kind of process is very important to keep things uniform, and so that you don't do like to educate your stakeholders, to work with different stakeholder. Some process are required for better executions. Am I answering your question? I think you asked me several things.
Yeah.
Yeah, ma'am. This one. Another thing is that like how to get the feedback from user and how you optimize the while optimizing the business objective, and how frequently you get the feedback from user.
Okay, it depends. Like how you manage your project is, I try to meet with my customers, like how, like it depends on your problem as well. So and it's your work style, and so I try to get like I have I schedule my meetings every week, like to get the feedback from the customers. Some people, they don't, they do it like end of the product like launch, and then they meet like once or twice. But I feel like more you meet your customers, the better feedback you get, and it helps you to improve your products. Ultimately, those are your customers, and I also feel like over communication is always better than under communication.
Okay. Thank you. Ma'am. One question I have, like when we start working on a AI company, okay, where maybe it may be a financial domain or telecom or retail or maybe some other domain, like how to handle the business team, like what happens generally, what we read some like some blogs and all, like sometimes a difficulty is there, that business team is not from the AI, maybe they don't have that particular AI knowledge, and may not have some kind of basic understanding of that, but they know that whole business part of thing and how actually we from that particular product what profit we should get from that AI based model. So how to handle sometimes that that communication needs to be set up. So how to handle that situation, ma'am? Like if you come across that kind of situation, so like
yeah, that that kind of situation, as a data scientist or AI scientist, you face all the time. Like working with them right from the beginning is very important, and I would say you have to have a thick skin too. Like you have, I mean, you have to bring a lot of iterations. So first of all, identifying, you have to build a trust And second of all, you have to be a good communicator and ask the right question. So if you want to build some solution, ask the right question. Like first understand the business, and also ask the right question. Try to identify what are the gaps and ask the right questions to your partner, and try to communicate not in technical terms but in plain language. Like, this is the issue, this is how, like, if you talk in technical terms, it's difficult to understand for them. And try to tell them like how you can help them. That is very important. Like, telling them like, if I do this kind of stuff, don't do that. Oh, I'll do this algorithm, that they don't care about that. They care about how you are going to help them. So just like telling them how you can help them with your skills, that is the most important thing to build a trust and get on board them into your solutions. And then ask them like also like the end product, like how they want the end product, like what is the specification they are looking for, like how they want to see it. Like, they are your customers, so you have to integrate their views onto your solutions. So that is important. So first of all, telling them how you are useful to them, and then how they like getting the feedback on how they want to see the product. And
Okay.
also timeline and all those things are important. And
Okay.
and I would say for all this kind of projects, data is important. And data is the, like, some of you must be you are already working, so you know how data is in the organization. And getting the right data and then integrating the data into different system is the most hardest things. And that's important. And I would recommend, like, before jumping into solutions, try to understand the data, try to understand like each and every data points you are using in your solutions. That is the key to the success of artificial intelligence.
Okay, ma'am. Thank you. And another most like in your presentation, there are few things like whatever you pointed out is very important. First thing is that like understanding the basic machine learning algorithms like linear regression, logistic regression, or
Yes, yes,
support
yes.
regression. So what personally I see some of the like persons who join this kind of data science job, so they like directly they want to skip all those things and directly jump into that hi-fi kind of deep learning method, CNN, all those things whatever they newly developed. But this understanding of the basic thing, and what you'll be knowing better is that this kind of retail and this financial domain, especially like there are huge amount of applications are there for this kind of machine learning algorithms, especially those fundamental machine learning algorithms. So that is very important. You pointed out. And second part is that those use cases, as I also mentioned. So those are very important for a person who wants to give some interview on data science. So those are very important. So these 2 points actually I thought like very important from this, apart from other important points you talk about.
Thank you.
Yes.
Yeah, and also like in organization, ultimately, not everybody understand like AI the way you understand. So so to convince them, it's not easy. Like if you use like as I told you, to apply AI in like forecasting, new product forecasting, it's very difficult, because if you write very complicated model, it's difficult to interpret. And once it's difficult to interpret, it's difficult to implement, because it's difficult to convince everybody in the organization that this is going to help. So that is why like simplicity is one of the factors in terms of implementation in organization.
Okay. Ma'am, another question I have is that before ChatGPT or this kind of generative AI-based model, so we explicitly use most of the ML algorithms, like maybe logistic regression, linear regression, and all. So how things will change after maybe 1 or 2 years? Because ChatGPT or this kind of models is doing almost everything whatever is done earlier by those models. So what will change actually, ma'am, for this kind of models after ChatGPT will be like very useful for this kind of domain? So what will change actually after?
I would say ChatGPT will not be integrated immediately to the organization, especially finance or my kind of organization, because it's a security threat. And also the ChatGPT, I don't know if you have read that ChatGPT can write very good coding, and they got all the material from GitHub, and it's like they are planning to sue the ChatGPT because it's kind of GitHub proprietary. So the data, all this data, I think it's like ChatGPT is getting from everywhere. So I don't, and once like sources start restricting themselves, it will be difficult for ChatGPT to use. But and instead of using like general ChatGPT, I would say like ChatGPT types of algorithm will be more applied on their on like different organizations. So for my organization, maybe they will develop their own ChatGPT because the technology is good, right? Like it will be very useful. So they will try to introduce their own ChatGPT, use the same technology, but not like generalize ChatGPT that we use every day. Like,
Okay. So it will be like that company, individual company will have individual this kind of algorithm.
yes.
Yes,
Like
ma'am.
Alexa, Google Home, it's been around for a long time, right? But like organization by themselves has not adopted uh, Alexa or Google Home to do their things.
Yes.
Right. Yeah, so they will use the technology for their like maybe they will build customized ChatGPT that will be useful for their organization.
Okay, ma'am. Thank you. So I think Azhar, we don't have any.
Yeah, I think we have taken up all the questions that were there in the comments. I think it has been a very extended session as well, so we can head towards the close of this event. So, with that, we'd like to thank you, ma'am, for such a wonderful talk. I'm sure the viewers have taken a lot of insights and about industry practice and how the retail business has applications for AI. And thank you so much for answering all the queries and doubts like in so much of detail. And yes, well, I think we can head towards the close of this. So then I would like to thank Dr. Sanghamitra Goswami once again for sparing time for I. And we actually look forward to a longer association with you, ma'am, like over
Sure.
this platform.
Yeah.
So with this, we'll come to the end of this event. And if there's any queries further, hopefully we'll be able to reach you
Sure,
accordingly.
definitely. Yeah.
Yeah,
Thank
thank you
you.
so
Thank
much,
you
ma'am.
so much. It's a great initiative, and I wish you all the best, and wish you like this will reach more and more students for their benefit. Thank
Thank
you.
you.
And if you
Thank you.
listen, just yeah, send me a mail. Thank you.
Thank you, ma'am.
Thank you, ma'am.
So
Bye.
yeah.